Hi everyone and welcome. In today's lesson we're looking at equations with identities and we are still going to determine the general solution. Now here is our example. 2 sine 2x minus 3 cosine x is equal to 0, and obviously we want to find the general solution for x. Now this lesson is about identities. Now, when we have a trigonometric equation, we always want to identify what type of equation we are busy with so that we can plan ahead. Now, what I'm showing you today is why will we use identities for specific examples. Now, here we go. So here we have a sine function with an angle of 2x and a cosine function with the angle x. So these angles are not the same, so we cannot use the quotient identity. Now the next thing that you learned was we're going to use reduction formula, but this time we cannot use the reduction formula. Now here's the important part. Why not? Because these coefficients or these amplitudes in trigonometry is not equal to a 1. It's a 2 and a 3. So that means we cannot use reduction formula and we are going to have to use identities. Now which one of these can we change? Well, we can change the sine double angle to its sine double angle identity. So we're going to leave the 2 on the outside, we're going to open brackets, and in the place of the sine double angle we're going to put 2 cosine x sine x, close the bracket, minus 3 cosine x is equal to 0. Then we multiply this 2 in and we get 4 cosine x sine x minus 3 cosine x is equal to 0. Now we still cannot use the quotient identity, but we can change this left side into one term by factorizing. So I can take a cosine x from each of these terms and I have a cosine x and then in brackets 4 sine x minus 3. So the cosine x was the common factor and that is equal to 0. Now we have a zero product rule, and from here you all know what to do. So we will say cosine x is equal to 0, or we will say 4 sine x minus 3 is equal to 0. So then on this side we're going to take the cosine over as its inverse, and we will say x is equal to the cosine to the power of minus 1, and we take this ratio and put it in brackets. We do the calculation on our calculator, and this is our reference angle for this part. Now we will say or, and then we will look at this half of this example, and then we will take the minus 3 to the other side. It becomes a positive 3, and then we will divide with this coefficient, and then we have sine x is equal to 3 over 4. Then we take the sine over as its inverse, and x is equal to sine to the power of minus 1, and we take the ratio and we put it in brackets. We do this part on our calculator, and then we end up with our other reference angle, and there it is. Now we have two reference angles. We've got this part and this part. So we start with this, and after we underlined our reference angles, we have to go and figure out in which quadrants we belong. So cosine x is equal to 0. We always treat 0 as a positive. So in which quadrants is a cosine function positive? In the first quadrant and in the fourth quadrant. So I write down quadrant 1, and then I say x is equal to my reference angle, which is 90 degrees plus 360 degrees times k. And then we also have quadrant 4, and that is 360 minus our reference angle. So we will say x is equal to 360 degrees minus our reference angle plus 360 degrees times k. And that leaves us with x is equal to 270 degrees plus 360 degrees times k. Now we go to this half, and this is a sine function that is also a positive ratio, and a sine function is positive in quadrant 1 and in quadrant 2. So I write down quadrant 1, and x is equal to 48,59 degrees, and here I can round off, plus 360 degrees times k. And then we're also working in quadrant 2, so we have to say 180 degrees minus the reference angle, and we have x is equal to 180 degrees minus our reference angle plus 360 degrees times k, and x is equal to 131,41 degrees plus 360 degrees times k. Now let's go and look at another example. Now here is another example that can help us identify some clues so that we know we're definitely going to use identities. We again want to determine the general solution for this example. We've got cosine 2x minus 3 sine x equals minus 1. Now before we start trigonometric equations, we always want to identify what we're dealing with. Well, we've got a cosine function with an angle 2x and a sine function with an angle x. Now these two angles are not the same. So from this equation I can spot two reasons why we will not use the quotient identity. The first reason is the angles are not the same, and the second reason is there is an extra term here. Okay, it's not a zero. So what do we do next? We try and make the two functions the same with reduction formula, but we cannot use reduction formula. Why not? Because this amplitude is not a 1. One of our functions has an amplitude that is not a 1. Okay, so therefore we're not going to use reduction formula. So that means we only have identities left. So before we're going to apply identities, we want to move all our terms to one side because later on we are going to have to factorize. So let's do that. Cosine 2x minus 3 sine x plus 1 equals 0. Now which one of these functions can I change with an identity? Well, this cosine double angle. Now what identity will we use? Which one of the three? Well, in identities we learned that we want to use the 1 so that we can get rid of this plus 1. But in equations we're not going to do that. We want all our functions to be exactly the same function. So we want to change this so that it becomes a sine function. So therefore we use this identity. 1 minus 2 sine squared x in brackets minus 3 sine x plus 1 equals 0. Then we multiply in this 1. Well, we didn't have to do it, but I want to show you all the steps. And then we have 1 minus 2 sine squared x minus 3 sine x plus 1 equals 0. And then we can simplify this part with this 1 plus 1, which will give us a 2. And we have minus 2 sine squared x minus 3 sine x plus 2 equals 0. Now this is a trinomial, but I still cannot factorize it because there's a minus in front of this term with the square. So we're going to multiply with the minus all the way through, and we have 2 sine squared x plus 3 sine x minus 2 equals 0. Now we can factorize this trinomial. And again, this lesson is not about the factorization, but here's the answer. So we end up with this bracket, 2 sine x minus 1, and in the other bracket we've got sine x plus 2, and that is equal to 0. This is a zero product rule, so we equate this bracket to 0 and we equate this bracket to 0. So on this side I'm going to do it all in one step. The minus 1 will go over and we will divide with the coefficient, so we end up with sine x is equal to 1 over 2, and then we move the sine function as its inverse, and x is equal to sine to the power of minus 1, and we take this ratio and put it in brackets, and once we do this on our calculator we end up with our reference angle. Then we have OR, and if we equate this bracket to 0 we will have sine x is equal to minus 2. Now this part will have no solution. Now why will this be no solution? Well, what is a sine function? A sine function is the ratio of the opposite side over the hypotenuse. Now if I look at this ratio, it's minus 2 over 1. Now how can the opposite side be longer than the hypotenuse in a right angled triangle? It's impossible. So therefore we have no solution. So we only have one reference angle. So our job from here is we want to go and see in what quadrants we need to work. So sine x is equal to a positive ratio. We're working in quadrant 1 and in quadrant 2. So I write down quadrant 1, x is equal to 30 degrees plus 360 degrees times k, and in quadrant 2 we will take this critical point minus the reference angle, and we have 180 degrees minus the reference angle plus 360 degrees times k, which leaves us with 150 degrees plus 360 degrees times k. And there we go. So I hope throughout this lesson you learned what to look out for so that we know we are going to have to use identities in our equations. See you again next time. Bye.